Hello, myself Sudhir Bhagwan Kumbar, Assistant Professor, Department of Chemistry, Dehwadi College, Dehwadi. In this video, I am going to revise the topic solid state from the syllabus of BSc third year, semester 6th. Let's see first types of solid. There are two types of solid. Let's see first amorphous solid. It is the solids which have no definite geometrical shape and no regular arrangement of atoms. The example of amorphous solid is talcum powder. The nature of talcum powder is smooth. Because of that, it comes under amorphous type of solid. The second type of solid is crystalline solid. It is the solid which have definite geometrical shape and exhibit regular arrangement of structural units. The example of crystalline solid is sugar. The sugar, the nature of sugar is crystalline. It is in the form of crystal. Because of that, the sugar is comes under crystalline type of solid. Crystallography. It is the branch of science which deals with the study of geometry, properties and structure of crystals. The aspect of study of the crystals. There are two aspects of study of the crystals. The first aspect of study of crystal is the examination of external form of crystal. The second aspect is the elucidation of the internal structure of the crystal. Point. The atom, ion or molecule in the crystal structure is called as a point or structural unit. In this figure, the red circles that is known as atoms, ions or molecules. This atom, ion or molecule that present in the crystal lattice. Lattice, a systematic and symmetrical arrangement or network of points is called lattice. Space lattice, the three-dimensional arrangement of points in a space called space lattice. The second term is the lattice. Here, this is the crystal. In this crystal, we observed the systematic arrangement of the points within the crystal. This is called as a lattice. Lattice points. The position occupied by the particle in the crystal lattice are called as a lattice point or also termed as a lattice sites. So in this figure, these red circles, these are also called as a ions, molecules. These occupy the position in this particular lattice. The position is the corner. So this is called as a lattice point. So this is also lattice point, this is also lattice point, this is also lattice point. So every red circle that occupy the position of this cube is termed as a lattice point. Faces of the crystal. The lattices are bound by surfaces which are generally planar, and these surfaces are called faces of the crystal. Interfacial angle. The angle between the two intersecting faces is called as an interfacial angle. Let's observe this figure. Here, this is the phase first, this is the phase second, and the angle between these two faces are called as a interfacial angle. The angle present in between the phase first and phase second. Lattice plane. The structural unit or points, that is atoms, ions or molecules, can be visualized as arranged in a number of parallel and equidistant planes called as a lattice plane. So in this first figure, these blue rectangles that are situated at equal distance from each other, that is called as equidistance, uh, that are in equal distance from each other. These planes are called as a lattice plane. The next term is the unit cell. It is a smaller unit in which the crystal can be subdivided without losing its essential properties, is called as a unit cell. Laws of crystallography. The law of constancy of interfacial angle. This is the first law of crystallography. It states that the shape and size of a crystal may vary with the conditions under which crystallization occurs, but the angle between the two faces are always constant. If you observe the figure, this figure contains three crystals. The shape of these three crystals are different, but the interfacial angle theta is the same, that is 90 degree. The second law of crystallography is the law of rational indices. It states that it is possible to select the three coordinate axes of unit distances such that the ratio between the intercept on these axes for different faces of a crystal can always be expressed by rational number, that is simple integral like 1, 2, 3 or fractions of whole number. The third law of crystallography is the law of crystal symmetry. All of the same substances possess the same element of symmetry is the statement of the law of crystal symmetry. The crystal symmetry is of three types. The first one is the plane of symmetry. The crystal is said to have the plane of symmetry when it can be divided by an imaginary plane into two equal axes in a such a way that one part is exactly mirror image of other part. So this is the cube, simple cubic system. This is the plane. If you observe this plane divide this crystal into two equal half. So this is called as a plane of symmetry. The second crystal symmetry is the axis of symmetry. It is an imaginary line about which the crystal may be rotated such that it presents exactly the same appearance more than once during the complete rotation. This is the two-fold axis of symmetry. This is three-fold axis of symmetry. This is four-fold axis of symmetry. The third crystal symmetry is the center of symmetry. It is a point inside a crystal such that any line drawn through it will intersect the surface of the crystal at equal distances on either side as shown in figure.